ahead with a few more problems in probability and statistics related to Bernoulli's principle and geometric series. More problems means more practice and better understanding. I hope this is very clear to everyone. But before that, let's cover some key points. This might seem redundant to many, but this will help build a solid base. So first is occurrence of event A in a sample space is considered success, okay? Non-occurrence of A is considered a failure. Pretty straightforward. Two outcomes, success or failure. It's denoted by P of A, which means probability of a success of having an event A. Now, in Bernoulli's trial, you have sample spaces success or failure with P success given as P. Or 0, 1, these are two outcomes. P1 is P, P0 is 1 minus P. Pretty straightforward, okay? So let's do some problems like we did yesterday. Let me make some room, some space here. Okay. So the first question that we have here is, in a lottery scheme, tickets are numbered from 1 to 100. When you purchase a ticket, you will get a random ticket number and you will win the lottery if the number turns out to be 37. What is the probability that you will win the lottery? Each number is equally likely to be chosen. Okay, so let's understand this problem. You have a lottery with tickets numbered from 1 to 100, okay? When you buy a ticket, a random number from 1 to 100 is assigned to you. You win the lottery only if the ticket turns out to be 37, okay? That's the only case. Each of the 100 numbers are equally likely, so all the outcomes are independent. So what is total possible outcome? Total outcome here is 100. You have 100 numbers. It's finite. If you remember from yesterday, we said there needs to be finite number of possibilities in Bernoulli's trial. Okay, so we have 100 outcomes. Each ticket number is equally likely to be assigned. So what are favorable outcomes? Favorable outcomes is we need 37 number. Okay, this is exactly one way to get it. So what's the probability? How many 37s are there? Just one. So probability is 1 over 100. So your answer is really simple. No, Bernoulli is here, 0.01. Probability of getting 37 is 0.01. Very simple. No need to make it any complex. Let's move ahead to question number 2, or key point 2. Key point 1 was very basic, so we are moving to something more advanced. Repeat a Bernoulli's trial multiple times independently. Perform n in independent Bernoulli trial. Outcome 0, 1, trial 0, 0, 1, trial 2 is 0, 1, 0, 2. Okay. So sample outcome 2n outcomes. Okay. Yeah. This is where geometric series is coming. Well, not geometric series, but n times of some trial which is going on. N times of a possible outcome. So sample space is 2n. This is outcome. Okay. And if let's say n is 3, you should have how many? 9 outcomes. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Yeah, makes sense. Here, what you are doing is you're defining sample space and outcome. So we know Bernoulli has only 2 outcomes, 0 and 1, success or failure. But sample space will depend on how many trials are going on, or how many number of times something is happening. Okay, if there's multiple times, for example, if you're tossing a coin 3 times, then what's the possible outcome, or the sample space? Sample space is going to be 2 to the power of 9, or 3, sorry. Total 9 outcomes. First coin, second coin, third coin. First coin, second coin, third coin. Will give you 2 possible outcomes, 2 definite outcomes in all these events. So total there are 9 sample space. Let's see an example to better understand this problem. It's very intuitive. I know text looks heavy, but when you start solving the problem, it's not that heavy. It's pretty straightforward. It's just the language that they use to confuse, which is difficult. So let's read the problem. In a 3-match ODI cricket series between India and Australia, any team will win the series if it wins at least 2 out of 3 matches. The series is announced to play in India, and the probability of winning a match by India is 60%. Also assume that the result of each match is independent. Assume that every cricket match results in win, W, or loss, L. List out the probability of possible winning situations of India. There you go. Let's break down the problem. There are three matches, so we know matches are three. For each match, India has probability of winning, which is 60%. So P India winning is 60% or 0.6. Each match is independent. India needs to win at least two out of three. If you remember the Ronaldo and Messi's problem from yesterday, you will understand what this is. So if to win the series, India needs to win two out of three matches. Okay. So uh, we need to represent the win and the loss. Okay. So if India won, it will be represented as one, because this is one. And if India lost, loss will be zero. So each three-match sequence looks like strings of zeros and ones. So let's say 0-1-1 means India lost first match but won the next two match, and that's why it won the series. Okay, this is just an example. Um, so let's see how all possible win-loss sequences. What's the win-loss sequence? We know they are playing three matches. So how many matches are there? Three and three. What's the possible outcome? Outcome in Bernoulli, as we have seen, is two. Okay. So what is the sample space? How many possible outcomes are there if there are three matches? 2 to the power of 3, which is 8 possible ways the results can turn out. If they play three matches, there are 8 possible ways the outcome of a match can be decided in three scenarios. What are those scenarios? Let's list them out for your better understanding. 1-1-1, which means India won all the match. Okay. Then we have 1-1-0, which means India won first two match. Then we have 1-0-1. I'm not going to write it. It's India won first and last match. Then we have 0-1-1. India won last two matches. And that's how India won the series. Okay. But you will see there are only 4 possibilities here. Okay, let me explain. So there are 2 to the power of 3, which is 8 possible ways the results can turn out. But we have to be careful. We have to be careful about winning situations. So only outcome where India win at least 2 matches are 4, which are these. Besides these 4 scenarios, there are 4 more scenarios where India did not win, but we don't care about those. Okay, I hope that makes sense. Now, when we do probability of India winning the entire series, which means India won 2 out of 3 match, then we have to find individual probability. So to find individual probability, I'm going to make some space here. So let's take case 1. Case 1 is 1,1,1, which means India won all the matches. So what is going to be the probability? Probability is going to be 0.6 times 0.6 times 0.6. It is 0.216. Okay. India won first two matches but lost the last one. It's going to be 0.6 times 0.6 times 0.4. Again, 0.144. And rest all are 2 matches. So what I'm going to do is quickly 101, 011. We'll also have 0.14 probability, 0.14 probability. Now, total probability of India winning a series is, okay, the question never asks that. Okay, the question is not asking the total probability, just the correct option. So correct options is number 1. The correct option here was 0.01, and correct option here is option A. 011 will have 0.144, 101 will have 0.144, 110 will have 0.144, and 111 will have 0.216. That's the right answer. This will show India won all the scenarios and the probabilities where India won the series. Okay, let's move to the next key point, which is an important one. So perform an independent Bernoulli trials. So perform an independent Bernoulli trials. Outcome is number of successes, which we will denote B and P, or B in short. Sample spaces are 1, 2, in general B and P. Okay, this is nothing. This is just a general description of Bernoulli principle. Nothing to they are showcasing how they are deriving to that conclusion of this formula. So nothing very substantive is being told here. Let's just go to our questions, which will help us learn better. Question says, in a three-match ODI cricket series between India and Australia, any team wins. Okay, this is, I think, the previous question. Same as the previous question, yeah. The series is announced to play in India, and the probability of India winning is 60%. Also assume that the result of each match is independent. Assume that every cricket match results in a win. What is the probability India will win the series? This is slightly different from what we have studied before. Okay, let me just start. India plays three matches against, as you've seen, nothing new here. Three matches played by India. Each match is a win or loss. Uh, India wins a single match, the probability is 0.6. India losing is 0.4, and independent, okay. Because every match has two outcomes, win or lose, and there are three matches, total number of possible result sequence is 8. We have seen this. 2 to the power of n, 2 to 3 is 8. Sample space is 8. So we have 8 possibilities. Win, 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 lose, win, lose, win, lose, win, 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 lose, 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 win, lose, and then we have lose, lose, win, lose, lose, lose. Okay. Then you have to count how many of these sequences gives India greater than 2 wins. So how many are there? There are 4 sequences, exactly like the previous question. Now, because matches are independent, multiply the probabilities. We have done that. Win, win, lose, win, win, lose. So you have so win, win, lose, and all sequence with exactly 2 wins have the same probability. So how many were there? 0.6 times 0.4 is 0.144. So there are 3 sequences. We have seen this before. There are 3 sequences which are same. So you can multiply it by 3 and you get the answer as 0.432. Now, WWW sequence has probability of, so all win will have the probability of 0.216. Probability of win, win, win. 216, okay? Now, all you have to do is just simply add to find the total probability. This is the part that we missed in the previous question. 0.216 plus 0.432, and your resulting answer is going to be 0.648. This is where we left off. We didn't do the total probability in this question. That's what we did here. Okay, I think this makes sense. Very simple. Let's move to the next question. In the probability that a film made by the director XYZ will make a box office collection of more than 100 CR, it's just an Indian value, is 0.7. Suppose that the director is planning to make 7 more movies. Assume that the collection of each movie is independent of other. What is the probability that exactly 5 out of 7 movies will make collection of more than 100 CR roads? Okay. I think I understood the problem. Let's just break this out. In the hints, they are giving binomial equation, binomial trial equation. Let's break down the problem. So the problem here is a director makes 7 independent movies. Okay, so there are 7 movies. Next is each movie, the chances to earn more than 100 CR is 0.7. Find the probability that exactly 5 of the 7 movies cross the 100 crore marks. Exactly is what we are looking here. Not at least, not like we did before in the previous section yesterday that we did at least, and we were solving at least. Here we are doing exactly 5 out of 7 movies uh, getting 100 crores. It's a unit of number. Okay. So recognize the setup. Fixed. How many trials are there? Trials are 7 movies. Each trial has 2 outcomes: a hit or box office hit or box office failure. So probability of hits is 0.7. Hit means getting more than 100 crore rupees. Of a flop or failure is 0.3. That's your probability. So how many do we need? If you remember, your n is 7. This is your n. Your 2 probabilities are 0.7 and 3. And then your k, what's your desired outcome? Is k equals 5. Exactly 5 is what we want. Now, all we have to do is plug the numbers. 7 factorial 5 times, what's the probability of win? It's 0. If you remember, this is 0.7. We want exactly 5 times 1 minus p is 0.3 to the power of 2. And this will give you the result. Power of 2, you know why I did power of 2. Okay, let me just do it here. So it's easier. It's 7 minus 5. That's why it's power of 2. Your final answer is going to be 0.3175. You round up to 0.318. Okay. So this is your probability of getting exactly 5 out of 7 movies hit. I think this was also very clear. And we are going to geometric distribution. Geometric distribution is somewhat tricky. So geometric distribution perform independent Bernoulli trial indefinitely. So the trials are going indefinitely. Now, Bernoulli has a fixed time. Geometric distribution does not. Outcome is going to be number of trials needed for first success, which we denote by GP or G. Sample space is 1, 2, 3, 4, 5, 6. There is no end to this sample space. First trial, second trial, but second trial has a common factor of P. If you remember, I told you yesterday, in geometric series, there's a common factor, which is P, which you take out to find the sum of infinite series. Let's solve the problem to get a good grasp. So you have question number 5. A company manufactures watches of a certain brand, and it is known that in a manufacturing process, on an average, 1 out of 20 watches is defective. Assume that different watches are defective independently. What is the probability that the full watch inspected is the first defective watch found? Very, very tricky question. How do we begin? Let's break down something. Always remember, I know this is a basic, but I have to spell this out for you. Trial is a single event. It's a single event, and it is called trial. Success is usually denoted by P. Failure is 1 minus P. These are very basic. K is a specific trial number. Specific trial number. Where we get our first success. So in this, K will be specific trial number, where we want the first success. Okay. So our question here is, what is the probability that the fourth watch inspected is the first defective watch? So how many trials are there? Trial is just one trial. Okay. So inspecting one watch at a time. Success is finding a defective watch. It says 1 out of 20 watch is defective, which means the probability of getting a defective watch is 0.05. Failure will be not getting any defective watch, which is 19 over 20 or 0.95. K is we want the first success to be on the fourth watch. K is 4. How does this question proceed? Trial is 1, which means you take first watch, We determine if it's a false or it's a defective or not. You go to the second, you go to the third, you go to the fourth. So you want your K, which means first defective watch will be on fourth. The fourth watch will be the first detective, not detective, but defective watch. Uh, this they're playing with the words. Don't look at the wording of this question. Obviously, when you're starting from first, when you say the first watch is defective, any watch which gets defective when you're starting will be the first watch getting defective. It's just that they are saying at fourth they found a defective watch. Okay, so in this you have to do simple math. Nothing too complicated here. We picked watch one, and it has to be good. It cannot be faulty because we want at four. Watch two, again, it needs to be a good watch. Watch three, it needs to be a good watch. Watch four, it has to be a defective watch, which is 0.05. Now, since all these events are independent, we just need to multiply their probabilities to get the event. So what's the total probability? So why are we multiplying and not adding? If you remember the principle of OR and AND. So here what we are doing is we want exactly fourth watch to be defective, which means first watch needs to be good, and the second watch needs to be good. The keyword here is and the third watch needs to be good, and the fourth watch needs to be defective, which means when we are saying and, everything needs to be multiplied. So 0.95 times 0.95 times 0.95 times 0.05. And your final probability is going to be 0.042. So 4% chances there that the first effective watch is going to be, the fourth watch will be the first defective watch. It's not difficult. They're just playing with the wording, which is kind of making it difficult. So you have to see, why are you not, the question will come. In this problem, why are we not using Bernoulli's principle and instead using geometric principle? Actually, we didn't use neither geometric nor Bernoulli's principle. We just did simple math here, simple arithmetic to find our answer. We know the trial, we know the probability of getting success, which means good watch, a bad watch, and a good watch. We wanted exactly fourth watch to be defective. If fourth watch is defective, then the first three needs to be perfect. And then we just applied the principle of and or to either add or multiply the individual probabilities to get the answer. So no geometric concept or geometric series concept was used here. Then we have a slightly difficult question. Sixth, what it says the probability that a student passes the qualifier test at IITM online degree is 0.6 in each attempt. Assume that successive attempts are independent. What is the probability that a given student will pass the qualifier test before the fourth attempt? Here we go. So in the previous question, what we were doing was finding exactly fourth watch is effective. Here, what we are doing is finding the probability that a given student will pass the qualifier before the fourth attempt. So the question says, what is the probability that a given student will pass the qualifier test before the fourth attempt? This question is slightly different. It is not asking for the probability of passing on a specific attempt, but by a certain time. So before the fourth attempt means the student passes on attempt one. Before fourth attempt, well, okay. Before fourth attempt means the student passes on attempt one, which is k equals 1, or attempt 2. Keyword here. Just remember the keyword. Keyword here is or, attempt 2, k2, or attempt 3. He needs to pass before 4th. So what we are looking at, we are looking at geometric probability of less than equal to 3 or less than 4. What are the trial? Trial is taking one test at a time, one test. What is success? Success is passing. The probability of passing is 0.6. Probability of failing is 0.4. So a student must pass on attempt 1, 2, 3. What is K? K is pass before 4, which means he needs to pass on first, second, and third. A hint is given, but let's do it without the hint. So probability of failing in attempt 1. How would you solve this problem? Just think about it. The person scores in the first attempt is 0.6. Okay? The person scores in the second attempt, which means he failed in the first one. And the person scored, I'm trying a different method, 0.4 times 0.6. He scored in the first attempt, he scored in the second attempt, which means he failed in the first attempt, then in the second he scored. Then the last one is 0.4 times 0.4, which means he failed in the first and second attempt, but lastly in 6 he won. So let's do the probability here. Let me open my calculator. 0.4 times 0.6 is 0.24. And then we have 0.4 times 0.4 times 0.6. You have 0.096. So your probability is going to be 0.096 plus 0.24 plus 0.6. Okay, so your total probability is 0.936. This is your answer. So answer for this question is 0.936. The answer for the previous question was 0.042. Now let's quickly explain what I did. It's very simple. Again, arithmetic use, no geometric series or anything. Although I will explain the formula. I didn't use the formula. What they're doing is they are subtracting the failures from the success. Okay, so what they're assuming is he failed in the first attempt, he failed in the 2 attempts, then he failed in the 3rd attempt. That's what they are trying to solve in this problem using this formula. But without formula, you can solve it. What I did is I assumed he passed in the first. That's one event. Event 1. Event 2, where he failed in the first exam, but in the second attempt he passed. That's the second case. The third case is he failed in the first attempt, second attempt as well, but in the last attempt, the third one, he passed. So your third event. And I said the keyword here is or, which means you need to add all these individual probabilities. When I did, I got 0.936. This is how I achieved the answer. Thank you.